Today we're going to show you the assembly building an in-tank return line filter. This is a very simple filter to manufacture. After you look at this, we're going to get into proper sizing of filters in the system. If this filter isn't sized properly, you'll end up with a lot of problems, and more than likely the filter will be in bypass. Well, here we're just showing the assembly of the filter cap and the bypass assembly. The assembly is attached to the cap for convenience and for less loose parts. The O-ring is installed into the filter head, and then the canister is attached to the filter porting head. There are two shipping screws that are installed to hold the canister to the head. They do not have to be removed when you install this into your system. We're inserting the element, and we're about to insert the cap. First we lube the O-rings so we don't have any cuts in the O-rings. And that's the assembly of the Schroeder in-tank filter. Now, in order to properly size a filter and get the correct filter for your application, there's a few things you need to know. Number one, what is the most critical component? Now, this graph shows various components and what their ISO codes should be. Now, these codes were not determined by Schroeder Industries, but were determined by the manufacturers of these particular type components. What this basically tells us, if we maintain these ISO codes that are shown on this graph, then the life of that particular component is indefinite. Then the next step you need to know is the flow, of course, the pressure. Where am I going to put my filters? Am I going to put them in a return line, or am I going to put them in a pressure line? Ideally, if you can put them in both places, it'll increase the life of your system. The next thing you need to know is, what is the viscosity of this fluid? The viscosity of the fluid determines the initial pressure drop. Now, what we try to do is we try to size these filters so that the pressure drop is no more than 50% of what the bypass setting is. All right, this chart is showing us basically the formula, which is the element delta P equals the flow times the element delta P factor times the viscosity. Now, these delta P factors, as you see here, is three columns, and these delta P factors are determined using 150 SSU fluid. Now, you need to know this because to size it properly, we want you to size this filter so the clean overall delta P, now that's through the element and the housing, does not exceed 50% of the bypass setting. In the case of the Schroeder filters, the majority of the bypasses are set at 40 psi. This slide shows you the pressure drop across a particular housing. You need to know this too, and usually the viscosity does not affect this curve until you get into viscosities that are almost a solid. But in this particular case, what we try to do is you take this, determine whatever flow you're running at, look at what the pressure drop is at that flow, and add it to your clean element drop. This gives you your total overall drop across the housing. If you follow these instructions, or you go online and into our catalog, in the first section of the catalog, the principles of filtration, all these formulas and all these graphs are available there, plus the graphs are on every page that the filters are on. If you have any questions, you can call us or see us on the web at www.schroederindustries.com.